Have you ever sat down and really thought about whether all the big questions that philosophers grapple with, can ultimately be boiled down to science and logic?
Yeah.
Is there a way to really ground all of these deep philosophical inquiries in the precision of science and the rigor of logic? That's what we're diving into today on the Deep Dive.
Love it.
We're going to be looking at logical empiricism.
That's good.
And for you, our listener, a philosopher. You're obviously very familiar with this. But we're going to be doing this deep dive based on the Stanford Encyclopedia of Philosophy excerpts that you sent us. So our mission today is to kind of unpack this whole movement of logical empiricism, or figure out what it was really all about, what they were concerned with, and then how it's continued to affect philosophy as we know it today. So yeah, ready to jump in.
Let's do it. I think one of the most fascinating things right off the bat is that logical empiricism, it wasn't like a rigid system. It was more a movement, right? A kind of a current going through Europe and America in the 20th century. And even the term empiricism itself, there was debate about what that meant.
Okay, so less about a single set of doctrines and more like a shared project among thinkers who are kind of all moving in the same direction, even if their ideas don't always line up perfectly.
Yeah, and it was less about fixed answers and more about an approach to thinking about problems and the sources you sent, even the idea of empiricism itself. Not everyone agreed exactly on what that meant or what it meant for knowledge.
Got it. So more about the journey and the shared questions rather than reaching a fixed destination.
Exactly. And this approach, right, this journey was really shaped by this rise of science. So the unifying concern, if you will, was this idea of scientific methodology being central to philosophical inquiry. And within that, they're really focused on logic and mathematics as kind of the bedrock of any rigorous philosophical project. Now, this is where it gets interesting with the language. We throw around logical empiricism and logical positivism almost interchangeably, but it seems like logical empiricism is the broader term. The Berlin group actually tried to avoid positivism.
Interesting. Why is that?
Not entirely clear, though some speculate it had to do with distancing themselves from earlier, more naive forms of positivism that perhaps were seen as too simplistic or overly reliant on a narrow conception of sensory experience. Whereas A.J. Ayer, a prominent British philosopher influenced by the movement, actually called himself a logical positivist.
So a bit of a terminological dance there. But in terms of the main players and the centers of this movement, who are we talking about?
Well, you've got the Vienna Circle, which I'm sure our listener, being a philosopher, is very familiar with.
Oh, for sure.
With Moritz Schlick as a central figure. You've also got the Berlin Society for Empirical Philosophy, led by Hans Reichenbach. But the thing is, this influence, it wasn't confined to these groups. It spread to thinkers and institutions across England, France, Scandinavia, even the U.S. and China.
Wow.
We're talking big names. People like Hans Hahn, Rudolf Carnap, Otto Neurath. Have you heard of Kurt Gödel?
Yeah, of course, Gödel.
It was in the mix, too.
Wow. That's surprising. I mean, especially given his later work, kind of leaning towards mathematical Platonism. It really speaks to the kind of intellectual diversity within this movement.
Absolutely. It was a dynamic and a lot of times a conflicting mix of ideas and approaches.
And not everyone explicitly labeled themselves as part of this movement, right?
That's the thing. Many were influenced by it,
right,
or engaged with its ideas, but they didn't necessarily wear the logical empiricist badge, so to speak. Yeah. And you can see how this movement then starts to shift geographically. In the 1930s, with the rise of Nazism and the political turmoil in Europe, a lot of these thinkers, they had to flee, right? They emigrated to the U.S.,
right,
and they brought these ideas with them. And this had a huge impact, on American philosophy, right?
Huge.
We're talking guys like Nelson Goodman, Ernest Nagel. You've got Reichenbach's students, too, Hilary Putnam and Wesley Salmon. They were really central to this kind of transplantation of logical empiricism to American soil. But eventually, by the 70s, right, this movement, it kind of lost its cohesiveness.
Okay.
It sort of dissolved as a unified entity. But here's the thing. Its influence didn't just disappear.
Right.
It seeped into all these different areas of philosophy. And what's interesting is that recent research, like the sources you mentioned, shows there was actually a lot more diversity and nuance within the movement than we often give it credit for. It wasn't this monolithic entity.
Right. It had internal debates, different interpretations. It was alive.
Exactly. And many of the critiques that came later, they were actually anticipated and debated by the logical empiricists themselves.
So much more self-aware than the common narrative often suggests. And speaking of narratives, the The source you sent also connects logical empiricism with these broader cultural trends.
Right.
So how does it fit into the bigger picture?
Well, if you look at Europe in the early 20th century, you've got this rise of modernism, right?
Yeah.
And it's not just in philosophy. Think about art movements like the Neusachlichkeit, this emphasis on objectivity and functionality, or the Bauhaus in architecture, where they're all about rational design,
Right.
integrating form and function. You can see the same spirit, right? This emphasis on clarity, reason, and a break from tradition and logical empiricism.
So there's a kind of shared aesthetic sensibility at play here. A rejection of the overly ornate, the obscure, the purely subjective in favor of clarity, precision, and a focus on what works, what's functional.
Right, and politically right.
Yeah.
We're talking movements like the New Deal and the Great Society. They're also about progress, reform, but based on reason, based on evidence.
Yeah. It's almost like the Bauhaus idea of functional design mirroring the logical empiricists' drive for a functional philosophical language.
Exactly.
Stripped down, clear.
Yeah.
No unnecessary metaphysical baggage.
Exactly. They wanted a philosophy that was as efficient and clear as a well-designed machine.
That's a great analogy.
But to really get their motivations, we have to look at the state of philosophy at the time. By the 20th century, most sciences, they'd become like their own fields. They didn't need philosophy as much anymore.
Yeah, right. So math, physics, chemistry, biology, even the social sciences were starting to emerge as independent disciplines, pursuing their own methods and questions. Psychology, too, was in the process of breaking away from its philosophical roots.
Right. So it was like philosophy was losing its turf. So it raised this question: what's left for philosophy to do? Where does it fit in? Some people said, well, philosophy, it deals with these like deeper truths beyond what science can grasp.
Oh, yeah.
That it uses intuition and speculation to access realms that science can't reach. But this is exactly what the logical empiricists pushed back against. Carnap even had this specific term for it, metaphysics, though he meant it a bit differently than how we might use it today. To them, it wasn't just that these deeper truths were unreachable. They saw this kind of thinking as actually harmful, leading to all sorts of problems.
Okay.
They wanted to put philosophy on a more scientific footing. But scientific didn't necessarily mean always doing experiments like in physics. It was more about a certain kind of rigor, a commitment to clear thinking, and to rooting philosophical claims in something more solid than just speculation.
So it wasn't necessarily about turning philosophy into a science, but rather about adopting a more scientific attitude in how they approached philosophical questions.
Yes, exactly. And specific scientific developments really fueled this shift. Like, have you ever heard of non-Euclidean geometries?
Oh, yeah.
Or Einstein's theory of relativity?
Yeah, of course. Those are big ones.
Those were game changers.
Totally.
Especially for the logical empiricists who'd been influenced by Kant earlier on.
Right, because Kant thought that Euclidean geometry, the kind we learned in school, was like built into our minds. That it was a priori, a necessary truth about how we experience the world. But these new geometries in Einstein's physics, they showed that, hey, maybe there are other ways to understand space and time, ways that don't fit Kant's picture.
Exactly. And it wasn't just that they were logically possible. These alternative geometries actually made better predictions about the physical world than Euclidean geometry did. So it really forced them to rethink how math and logic connect to our experience.
It was like the rug was pulled out from under them. They had to find a new foundation.
Right. And it wasn't just happening in a vacuum. The world around them was falling apart. World War I, economic depression, political extremism. It felt like everything was unstable, like the old ways of thinking weren't working.
Right. There was a sense of urgency. Like philosophy needed to offer something more concrete, something that could help address the very real problems the world was facing.
Exactly. For the logical empiricists, all this pointed to a need for a new way of thinking, one grounded in science and reason, something they called a scientific world conception. They really saw this as a project of liberation, of social and intellectual reform, kind of like a new enlightenment.
So in that context, logic wasn't just an abstract tool. It was a weapon against bad ideas.
Yeah.
Against dogma, against unreason.
Exactly. It was about clearing the ground for a better world. And this is where the advancements in logic itself become so important. Like, have you ever heard of Bolzano or Russell?
Oh, yeah.
Wittgenstein?
Of course.
These guys were pioneers in mathematical logic.
Yeah.
And for the logical empiricists, this new logic, it was like having a brand new toolkit.
Right.
It gave them a precise way to analyze arguments, to break down complex ideas into their basic parts, to really scrutinize what we mean when we say things. And you can see this influence, right, in how they approach some of the big philosophical problems, like the nature of knowledge, how we justify our beliefs, how we distinguish between meaningful statements and just babble.
And that brings us to the heart of logical empiricism, right? Their core commitments.
Yeah.
Let's start with empiricism itself.
Okay.
Their stance on metaphysics and this idea of verification that you were talking about.
So they were committed to empiricism,
Right.
which is the idea that all knowledge ultimately stems from experience.
Okay.
But here's the thing. What kind of experience are we talking about?
Right. Because there are so many different types of experience, and not all of them seem equally reliable or informative for building a solid foundation for knowledge.
Exactly. And the debate was about how far this dependence on experience went and what it meant for different kinds of knowledge. Especially tricky were things like logic and math.
Right. Like, how can you get 2 + 2 = 4 just from looking around?
Exactly. It doesn't seem like 2 + 2 = 4 is something you just observe, right? So how do you fit them into an empiricist worldview? Frege and Russell, they tried with logicism.
Trying to show that math is basically just logic in disguise.
Yeah.
And Wittgenstein, with his no-content theory of logic, also contributed to this project, right?
Right. The idea was that logic itself doesn't say anything about the world. It's just a tool, a way of manipulating symbols. So you're not really observing anything when you do logic. You're just playing with these formal rules.
Okay. But then how do you decide what's meaningful and what's not?
Well, that's where verification comes in. It was Wittgenstein who first proposed this radical idea. A statement is meaningful only if it can be verified through experience. In principle, you should be able to trace it back to some basic observations.
So it's like a test, right?
Yeah.
If a statement can't be linked back to something we can observe, then it's just empty talk.
Exactly.
It's like, show me the evidence, or it's meaningless.
Right. And the logical empiricists, they saw this as a powerful weapon against what they considered meaningless metaphysics.
Yeah.
You know, all these grand pronouncements about the nature of reality that couldn't be tested.
It's like they were trying to clean up philosophy, get rid of all the fluff, and just focus on the stuff that could be backed up by evidence.
Right. But then they ran into a problem.
Yeah.
What about the laws of science themselves?
Oh, right. Because those laws are about, like, universal truth, things that apply everywhere, not just to what we've observed so far.
Exactly. So how do you verify something that claims to be true about an infinite number of cases? A law of nature, you can't just check it for every single instance, right?
So their own criterions seem to rule out some of the most important parts of science.
Exactly.
That's a pretty big snag.
Yeah, and it led to a lot of debate and different interpretations of the verification principle. Some, like Schlick, tried to argue that laws weren't really statements, but more like rules for making predictions.
Okay.
But others, Carnap and Neurath particularly, they're often called the left wing of the Vienna Circle.
Okay.
They wanted a more flexible version of verificationism.
Right, because it seems like if you're too strict with your verification principle, you end up throwing out a lot of valuable knowledge.
Exactly. But coming up with a perfect version proved really difficult. The source you mentioned brings up A.J. Ayer. He had this formulation of verification in his book, Language, Truth, and Logic.
Oh, yeah.
That book was really influential.
Yeah.
But his version had this fatal flaw. He basically said that a sentence is meaningful if it can be empirically confirmed, even just in principle.
Yeah.
So either it directly implies something we can observe, or it helps us make observations about other sentences. But then people figured out that you could use this to make pretty much any sentence meaningful, even gibberish.
Wait, how?
Well, imagine you have some totally nonsensical statement, call it A. Okay,
Right.
You can just add to it. If A is true, then I'll observe O, where O is something you can actually observe.
Okay, so you're kind of smuggling in meaning through this conditional statement.
Exactly. Because now the whole thing implies something observable, so according to Ayer's version, it's meaningful, even though the original statement A was nonsense.
That's pretty clever. A clever loophole. So it sounds like they were always running into these walls trying to make verification work perfectly.
Yeah, even Hempel, who initially thought this was a great idea, later admitted it was probably a dead end. One thing they realized was that maybe focusing on whole sentences was the wrong approach. A sentence could have meaningless parts, but when combined with other sentences, even those with meaningless parts, the whole thing might seem to have empirical content when it really didn't.
So it's like trying to judge the quality of a cake just by looking at the individual ingredients. You need to taste the whole thing to really know.
Exactly.
No.
And it wasn't just about the ingredients themselves. The way they're combined mattered too.
So what did they do? Did they give up on verification?
Well, not entirely. Carnap, for example, he tried a different tactic. Instead of looking at whole sentences, he focused on the individual terms within them.
Okay.
This is in his 1956 paper, The Methodological Character of Theoretical Concepts. He basically said that observational terms have empirical content. Logical terms, they're just tools, they don't have content. And defined terms can be replaced by their definitions. So a basic, non-logical term has empirical content if it's part of a sentence that implies an observation sentence.
Okay. So it's like breaking down the sentence into its smallest meaningful units and then checking if those units have a connection to what we can observe.
Exactly. And this helped avoid some of the problems they had with sentence-level verificationism.
So, progress.
But it still had some issues. Some philosophers came up with counterexamples, showing that even this more refined version wasn't foolproof.
So it's kind of a never-ending battle.
In a way, yes. But they kept refining.
Okay.
They kept trying to patch things up. It shows how committed they were to this idea of grounding meaning and experience.
It's impressive, actually, their persistence.
It was a big project. But there was this even bigger problem looming.
Oh, yeah. What's that?
The principle of verification itself. Some people argued that it couldn't be verified. It was self-refuting.
Oh, right. Because if it's true that only verifiable statements are meaningful, then the principle of verification itself would have to be verifiable to be meaningful.
Exactly. And that was a big challenge. Ayer, he tried to get around this by saying the principle wasn't a factual claim, but a definition. It's like saying, by definition, anything we can't verify is meaningless.
But that seems kind of like cheating, doesn't it?
Yeah.
You can't just define away the problem.
Right. And that's what a lot of critics said. Like, why should anyone who believes in metaphysics be convinced by a definition that just declares their claims meaningless?
It's not really an argument.
No.
It's more like a dismissal.
Yeah, kind of hand-waving.
Okay. So what about Carnap? How did he deal with this?
Carnap had this thing called the principle of tolerance.
Okay.
And it was a big shift. He basically said there's no one right way to do logic or philosophy.
Okay.
It's all a matter of choice, of convention. Even empiricism itself, it's not like the only valid approach. It's just one way to structure our language, one way to talk about the world.
So for Carnap, philosophy became less about discovering absolute truths and more about choosing the best tools for the job.
Exactly.
And the principle of tolerance suggests that we should be open to different ways of doing philosophy, even if they don't fit our preferred framework.
Right. But this tolerance wasn't just about being nice. Carnap really thought that this way of thinking could help us get past all these pointless philosophical debates.
Okay, yeah.
Especially the ones about metaphysics that have been going on for centuries without really getting anywhere.
So how did the principle of tolerance help with verification?
Well, now verification is less a truth claim about what's meaningful and more like a proposal.
Okay.
A suggestion that, hey, what if we adopt this specific language where everything is verifiable? And within that language, it would be true that there are no synthetic, unverifiable, yet meaningful sentences.
So it's like creating a self-contained system where the principle of verification holds by design.
Right. And the point wasn't necessarily to describe how we actually use language in everyday life. It was more about suggesting how we could use it to avoid philosophical muddles.
Like building a better philosophical mousetrap.
Yeah.
So a more practical and constructive approach to these problems of meaning and knowledge.
Right.
It's pretty radical when you think about it.
It really was a shift in how we think about what philosophy is for.
Yeah.
Instead of searching for ultimate truths, it's more about building tools for clear thinking, for understanding the world in a more rigorous way.
So philosophy as a kind of conceptual engineer.
Exactly. And that idea, that's had a huge impact, even on philosophers who don't agree with everything the logical empiricists said.
And this brings us to another key concept. Analyticity.
Right.
The distinction between analytic and synthetic statements.
Right.
What was their take on that, especially in relation to logic and math?
Okay, so traditionally, logic, math, geometry, they seemed different from empirical sciences, right? Their truths didn't seem to rely on observation. You don't need to do experiments to know that 2 + 2 = 4.
Right. It just seems true by definition.
Right. Philosophers like Leibniz, Hume, Kant, they all had different ideas about how to explain this. Kant, for instance, he thought logic was analytic, true by definition. But math and geometry, they were synthetic a priori, meaning true independently of experience, but not simply because of the meanings of words.
Okay.
The logical empiricists, they weren't convinced by this synthetic a priori stuff. They saw it as kind of mysterious, not grounded in anything solid.
So they were skeptical of this idea that there are truths about the world that we can know just by thinking, without any appeal to experience.
Exactly.
They wanted everything to be accountable to observation, one way or another.
Right.
So how did they handle math and logic?
Well, Russell had made a good case with logicism, the idea that math can be reduced to logic. So the logical empiricists, they took that ball and ran with it. They said, okay, let's just treat both logic and math as analytic.
Meaning that their truths are based on the meanings of the terms involved and the rules of logic, rather than on some special intuition or facts about the world.
Exactly. Their goal wasn't to say that logic and math are somehow less important. They wanted to bring them into the scientific fold, make them part of a unified picture of knowledge where everything ultimately stems from experience.
Okay, but didn't this distinction between analytic and synthetic lead to some confusion? Our source mentions that there are some common misconceptions about what they meant by analyticity.
Yeah, definitely. One big one is that they were obsessed with certainty.
Like analytic statements are certain, while synthetic ones are always open to doubt.
Right.
Because the logical empiricists were all about this idea that knowledge is ultimately based on observation, and observations can be wrong.
Yeah, and because they saw logic and math as based on linguistic conventions, they knew those conventions could change. So the truths that depended on those conventions weren't seen as absolutely certain either. It wasn't about finding some kind of ultimate foundation that couldn't be questioned. It was more about making clear what kinds of statements are answerable to what kind of evidence.
So kind of epistemic bookkeeping.
Yeah.
Keeping track of what justifies what.
Right.
And wasn't there also a misunderstanding that linguistic conventions can't really establish truth?
Yes, and it's a good point. But for the logical empiricists, analyticity, it applies to sentences, not to some abstract truth out there in the world, independent of language. And our conventions, our agreements about how we use language, they determine the meaning of those sentences. So once the meaning is fixed, an analytic sentence might be true just because of how we've decided to use the words.
Okay, so it's not that the world somehow conforms to our linguistic conventions.
Yeah.
It's more like our conventions establish the rules of the game. And within those rules, certain sentences are guaranteed to be true.
Yeah, like in chess. The rules of chess determine which moves are legal and which are not.
Right.
It's not that the pieces on the board somehow dictate the rules. The rules are external to the game itself.
I get it. So how did Carnap specifically deal with this analytic-synthetic distinction, especially given things like Gödel's incompleteness theorems that seem to complicate matters?
Well, in his book Logical Syntax of Language, Carnap got really technical.
Okay.
He defined analytic using this formal system.
Okay.
He talked about derivations, which are proofs within the system, and consequences, which are truths that follow from the system's rules. And he showed that for any mathematical sentence, either it or its negation is a consequence of the system's basic rules.
So even if you can't prove a specific sentence within the system, you can still show that it's either true or false based on the system's basic assumptions. And that helped them sidestep some of the problems raised by Gödel's theorems, which were about the limits of what could be proven within a formal system.
Right. Gödel showed there were limits to what you can prove within a system.
Yeah.
But Carnap was saying, look, even if you can't prove it, it still has a determinate truth value.
Okay.
It's either true or false within that framework. And this all ties back to Carnap's principle of tolerance, right?
Right, because the principle of tolerance suggests that the analytic-synthetic distinction isn't some absolute mind-independent thing. It's relative to the framework you choose.
Exactly. Different systems, different rules, different ways of drawing the line between analytic and synthetic. And Carnap even tried to extend the idea of analyticity to theoretical terms in science. He suggested that you could use the Ramsey sentence of a theory, which is basically a way to capture all the empirical content of a theory without using theoretical terms, to imply the theory itself as an analytic truth.
Okay, so it's like saying that once you've captured all the empirical stuff in a theory, the rest is basically just unpacking what's already implicit in that empirical content.
Right, but that particular idea, it's still being debated. And then comes Quine.
Oh yeah, Quine, that's a whole other can of worms.
Right. In his famous essay, Two Dogmas of Empiricism, he argued that this whole analytic-synthetic distinction, it was fundamentally flawed.
So he was questioning one of the central pillars of logical empiricism.
Yeah.
What was his beef with it?
Well, he said that there's no clear way to define analytic without ending up in a circle.
Like trying to define a word by using the same word in the definition?
Exactly.
Oh.
You know, like saying an analytic statement is one that's true analytically. It doesn't really tell you anything.
Right.
And he also argued that you can't just point to observation to ground the distinction either.
So for Quine, the analytic-synthetic distinction wasn't just fuzzy, it was potentially meaningless. And he had his own alternative picture of how knowledge works, which didn't rely on this distinction.
Right. He was more holistic.
Okay.
He saw our beliefs as a kind of web where everything is connected.
Okay.
And experience, it just tugs on the edges of this web, adjusting the whole thing.
So for Quine, it wasn't about separating analytic truths from synthetic ones.
No.
It was about understanding how the whole system of beliefs responds to evidence.
Exactly. And this sparked a huge debate. Carnap and others, they tried to defend the distinction, saying that Quine's criticisms weren't fatal. They argued that maybe he was asking too much, that maybe you don't need a perfect observation-based definition to make the distinction useful.
So a kind of pragmatic defense?
Yeah, and some even argued that Quine himself, in his later work, actually implied a way to understand analyticity.
So even if Quine didn't explicitly endorse the analytic-synthetic distinction, maybe he implicitly relied on something like it in his own thinking.
Right.
And this debate, it's still going on today.
Oh, yeah.
Philosophers are still arguing about whether the distinction is valid, whether it's useful.
But the important thing is that this debate, it pushed our understanding of how language works, how it connects to the world. It made us think harder about the nature of truth, about the limits of logic, about what we can really know.
Yeah, okay. So let's move on to another big one. The unity of science and this idea of reduction.
Okay.
This seems to be another place where the logical empiricists had strong opinions and where they ran into some controversy.
Yeah, they were really into this idea of a unified science, and it was especially important to the left wing, guys like Otto Neurath.
Okay.
But there are a lot of misunderstandings about what they meant by this.
Right.
It wasn't just about reducing everything to physics or saying that all sciences should use the exact same methods.
Right, because that would be pretty naive.
Yeah.
Different sciences obviously study different things,
Yeah.
and they need different tools for the job.
Exactly. For Neurath, the unity of science was more about a couple of things. First, he really wanted to bridge the gap between natural sciences and social sciences.
Okay.
Because back then, some people thought you couldn't study social phenomena scientifically, that it was too subjective, too messy,
Right.
that you needed some special kind of intuition or empathy to understand human behavior.
Like you couldn't capture it with equations or experiments.
Right. Neurath, he rejected this.
Okay.
He thought social sciences could be just as rigorous as natural sciences.
Yeah.
And even within natural sciences, he saw a lot of variation in methods.
So it was about respecting the complexity of different fields while still maintaining that they were all engaged in a fundamentally scientific project.
Exactly.
And what was the second thing Neurath was pushing for?
Well, he was also very politically minded.
Okay.
He really believed that for science to be effective in solving social problems, we needed more communication between different fields. So he wanted to create this universal jargon, a shared language that scientists from different disciplines could use to understand each other.
So the unity of science wasn't just an abstract philosophical ideal.
No.
It was a practical project for Neurath, motivated by this desire to use science to improve society.
Exactly. And he didn't want this to be a rigid top-down thing where everything is forced into a physics mold. He actually thought that grand reductionist projects were kind of misguided.